parallel plate capacitor has an area of 4.84 centimeters squared, and the plates are separated by 1.15 millimeters with air between them. It stores a charge of 468 picocoulombs. What is the potential difference across the plates of the capacitor? So, in this problem, they have given us an area and a distance of separation and a charge. So we are going to need to use an equation that utilizes all three of these values. So let's use the equation V, which is the potential difference. V is equal to Q, which is the magnitude of the charge, divided by epsilon naught, which is a constant, and the value is already a fixed value, which we don't have to worry about, multiplied by the area over the distance. And this will be the area of the parallel plate capacitor and the distance between the two plates that they have provided us with. So, the charge they have given us is 468 picocoulombs, but we have to convert that into coulombs. So the charge will be 468, and then to convert it into coulombs, we just have to multiply it by 10 to the negative 12th, and that is coulombs. The value for the constant epsilon naught is equal to 8.85 times 10 to the negative 12th. So now we have to do the area over the distance. So they gave us the area in centimeters squared, and we have to convert that into meters squared. So 4.84 centimeters squared is equal to 0.000484 meters squared over the distance, which they have given us in millimeters, and we have to convert that to meters. So 1.15 millimeters is equal to 0.00115 meters. And then we can close the parentheses there, and then we can just put all of this into the calculator, and the value that we get for the difference of potential across the two plates is 126 volts. So the second part of this question is asking for the magnitude of the uniform electric field in the region between the plates. And for this, we are going to use the equation E equals V over D. So that is the magnitude of the electric field equaling the voltage or the potential difference divided by the distance separating the two plates. So we just calculated V in the last part of the problem, so 126 volts, divided by the distance, which we will just use this distance that they gave us, and it has to be in meters again, so 0.00115 meters. And so we get 109,565, 109,565.2174, and this is going to be in volts per meter, and in scientific notation this would be 1.096 times 10 to the 5th volts per meter as the magnitude of the electric field between the two plates.